Hello and welcome back to another video. In this video, we'll study physical quantities and units, but this is part 1 of that. In this part, we'll study important concepts such as homogeneous equations, what is scalars and vectors. We'll even consider the differences between vector triangle and closed triangles, plus a lot more. In part 2 of this video, we'll study all about accuracy, precision, and uncertainty. We'll also discuss about errors, and of course, we'll have a lot of examples covering that. Alright, so let's start. Okay, we'll talk about physical quantities. What is physical quantities? Physical quantities is basically a feature of something that can be measured. For example, you can measure length, it's a physical quantity. You can measure the mass of an object, that's another physical quantity. Time, current, velocity, all of them are physical quantities. But let's say, if I say, for example, the physical quantity is 200. Is it a complete, do you understand what this is? Is this 200 liters? Is this 200 micrograms? You don't understand a physical quantity fully until you have the both magnitude and a unit. So unit is very important. I can write milliampere. So this is a physical quantity. If you have a range of values, you can fill those values in a table, something like this, and even plot a graph. Now this is milliampere, so you'll obviously not put this in a time under time. And velocity, but this is just an example. So remember, in the x-axis is always the independent variable, something that you are changing, and on the y-axis you have the dependent variable, something that is being changed because of the independent variable. And then when you're in the table, the first column has the x-axis, the second column has the y-axis. We write a slash and then the unit. Okay, if you see your value is divided by a number, for example 3 divided by 10 square seconds. This means this value is already divided by 10 square. So what is the real value? You have to multiply it by 10 square. So if you're writing it as seconds without divided by 10 square, this is going to be 100, because it's 1 multiplied by 10 square, and the second one is 200, the third one is 300. Base quantity means that all the quantities that we have are composed of one or a combination of these basic quantities. Let's write down the US unit. So for mass, it's going to be kilogram. For length, it's meters. Time is second. Electric current is amperes. Amount of substance is mole, something you have studied in chemistry a lot. And then you also have luminous intensity. We're not really going to study this during AS physics. Now for AS physics, it's important that you know how to make reasonable estimates of physical quantities within the syllabus. So that means as you're going through the syllabus and studying more chapters, be mindful of the quantities that you're studying. What is the estimate for a carton of orange juice? This is around 1 liter. You know your water bottles, the big water bottles are for 1 liters. What is the mass of a large car? It's about 200 kilograms. You can imagine multiple, it's obviously much heavier than a normal person. What is the mass of an adult? Now this is written as 1 times 10 square kilogram. There's obviously going to be a range. This is just an estimate, okay? What is the weight of an apple? 1 Newton. Now these are just estimates, so your answer is obviously not going to be exactly same. Now the first one is volume of an orange. If you notice, orange is basically a sphere. So we can use this formula 4/3 multiplied by pi times radius cubed. So the radius could be around 4. And your answer should be around 3 times 10 power 2 centimeter cube. I'm writing the answer in centimeters, centimeter cube for the volume. Next, change in gravitational potential energy of a child climbing 2 flights of stairs in the house. So I'm going to write 25 kilograms for the child multiplied by 9.81. That's going to remain same. What about the height? So we can say one flight of stairs could be 2 meters. The second flight of stairs could be another 2 meters or 4. So I'll just write 5 meters as a rough estimate. So your answer should be in the range of 1 to 2 kilojoules. Now, what is the volume of a human head? So again, this is like a sphere. So we can say 4/3 multiplied by pi radius cubed. So the radius is, let's say 10 power 3. This is centimeters, okay, 10 centimeters. So I'll divide this by 100 to convert this into meters. So this should be around 4 times 10 power negative 3 meter cube. Now what is the height of a room in a house? So you can look at the room near you and should be around 2 to 3 meters. Alright, now let's talk about significant figures. All non-zero numbers are significant figures. For example, the first one has 2 significant figures. The second one has 1, 2, 3, 4, 5 significant figures because there are 5 numbers. And finally, we have 4 significant figures because we have 4 numbers. Now, what if you have a 0 between numbers? That is considered a significant figure. So the first one has 1, 2, 3, 4, 5 significant figures, and the second one has 3 significant figures. Now what about zeros to the left? Are these part of the significant figures? No, they're not. You need to add them to make sense of the number. So in this question, you only have 2 significant figures, 3 and 8. Now what if the zeros are towards the right or towards the end? You have to use a scientific notation to make complete sense of it. So for example, if you look, the first one is 6 times 10 power 2. This has 1 significant figure only. The second one has 2 significant figures, and the last one has 3 significant figures. Now let's move on to these prefixes or quantities, which are very essential for physics. Now you might already know them, so if you can, try to do this on your own first, and if you are done, let's see. So let's say if you have 200 megajoules and you need to convert this into joules, what do? So you're going to multiply 200 multiplied by what is a mega? This is 10 power 6. Multiply this by 10 power 6 joule, and this is going to be 2 multiplied by 10 power 8 joules. So 200 megajoules is basically 2 times 10 power 8 joules. Now what if you want to convert from joules to megajoules? What do? So you just write down the number 2 times 10 power 8 joules, and then you're supposed to divide, okay? Divide by the number given here. So this is 10 power 6. Divide by 10 power 6 and you will get 200 megajoules. So when you want to remove your prefix and get the normal unit, you just multiply with the quantity that's given here, okay, all of them. When you want to get the unit back, for example mega, you're supposed to divide. Now what about 4000 milliliter times liter? So it's going to be 4000 multiplied by what is for milli? You have 10 power negative 3, so multiply this by 10 power negative 3, and this is going to be 4 liters. So what if you already have 4 liters and you need to convert this into milliliters? Divide by 10 power negative 3, and you're going to get 4000 milliliters back again. 1 microgram to 1 milligram, so we'll write 1 multiplied by what is it for micro? It is 10 power negative 6. So we'll write 1 multiplied by 10 power negative 6, and then you get grams, okay? So you already have grams, and you need to convert this into a prefix, which is milligram. So you have to divide by 10 power negative 3, and the answer will be 1 multiplied by 10 power negative 3 milligrams. First you converted micrograms into grams, and then you converted grams into milligrams to get your answer. So remember, when you want to remove your prefix, you have to multiply with these numbers, okay? When we are removing megajoules, we have to multiply by this number. Now what if when you want to add your prefix, you have to divide by any of these number. Remember to learn when you have negative powers and when you have positive powers, because if you don't write these negatives or positive, this is going to ruin your answer. So I hope that's easy to remember. It's very useful though. Now what if your units have powers? For example, in volume you write centimeter cube, meter cube. For areas you write square, right? Centimeter square, millimeter square. What if you need to convert in this way? So this is going to be 1000 multiplied by what is the what do we multiply for a centimeter? It's 10 power negative 2, and since we're removing the prefix, we have to multiply. This is going to be multiplied by 10 power negative 2. Now you have a cube here, right? Because this is volume. So you're just going to cube all of this. And this you're going to get 1 multiplied by 10 power negative 3 meter cube. Now if you look on the other side, so now you're adding a prefix, right? So you have to divide by any of the number, by this number. So this is going to be 6 divided by 10 power negative 3, because remember for milli it's 10 power negative 3. So you will write negative 3. Now you can see we have a square. So you're just going to square this. This is going to be 6 multiplied by 10 power 6 millimeter squared. Let's talk about derived units. So derived units is basically a combination of base units. We just studied these base units, which are very important for us. Now derived units are basically a combination of base units. So how do you find the base unit? You need to write down the formula. The symbol for density is rho, not the unit, okay? So what is the formula? Density equals rho equals to mass divided by volume. So what is the SI unit for mass? It's kilogram divided by volume, meter cube. So the base unit for density is kilogram per meter cube. What about pressure? So you know the SI unit for pressure is Pascal, but that is not the base unit. To write down the base unit, you need to write down the formula. Alright, now we'll discuss homogeneous equations, okay? So, homogeneous equations or balanced equations state that the right hand side and the left hand side have the same base units, right? It would be mathematically incorrect if you have an equal sign and the terms on each of these sides are not the same. So we will say that our equations are homogeneous if they have the same units. Let's write them down. So it's v equals to u plus at. V is velocity, so the unit is meter per second. This equals to, what about right hand side? U is initial velocity, so this is also meter per second, plus acceleration. Acceleration is meter per second square multiplied by, this dot represents multiplication, time is second. So if you simplify this, this is going to be ms minus 1 plus ms. Now okay, now if you probably know it, if you don't, when you're multiplying same number, same letters, s and s, you just have to add their exponents. So this is minus 2 plus 1 equals to minus 1. So this is going to be minus 1. Now we can say right hand side equals to ms minus 1, left hand side also equals to ms minus 1. If it's added, it's okay. You have to look at the unit. Now if this was instead of being added, if this was being multiplied, that's going to change everything and it wouldn't be balanced. Now let's look at another example. So for example, work done equals to gain in kinetic energy plus loss in potential energy, for example. Can you try to do this on your own first? Okay, so we know the unit for work done is joules, but joules is the SI unit, it's not the base unit. So let's write this in terms of base unit. Remember, what is the formula for work done? I'll write right hand side. So work done equals to force multiplied by distance. What is the formula for force? This equals to mass times acceleration. This is for force and then multiplied by distance. So mass equals to kilogram, acceleration equals to meter per second square, and distance is meters. So I will simplify this. This is kilogram meter square, because m1 1 plus 1 is 2, and then s minus 2. What about left hand side? This is going to be gain in ke plus loss in potential energy. What is the formula? It's half mv square plus mgh. Let's write down the units. So half has no unit, of course. This is going to be kilogram multiplied by velocity is meter per second square, meter per second square, plus kilogram for mass, and then g is acceleration of free fall, so meter per second square multiplied by height, which is also meters. Let's simplify this again. So this is going to be kilogram. Okay, now when you have bracket and then something and then power of something, you have to multiply them. Okay, so this is 1 and 2, so 1 multiplied by 2. This is going to be m square, and then s minus 1 multiplied by 2. This is going to be negative 2, plus kilogram meter square s minus 2. So you can say the unit is kilogram meter square s minus 2. Are they both balanced? Yes, they absolutely are. So this equation is also balanced. This is a homogeneous equation. Now we have these two practice questions. Try to do them on your own first. And if you're done, let's begin. So the first question says, find the base unit of k, where your equation is w equals to half kx squared. So you need to find the unit for k. You don't know what this value is, let's say. So to do that, let's make k as a subject, 2w over x squared. So 2 has obviously no units. W is work done. We just found out the unit for work done, kilogram meter square, and s minus 2. And then divide this by x squared. So x represents distance or extension. So it's going to be meter square. Now you can simply cancel these two. Kilogram s minus 2. Now if you want to know if this answer is correct, what you can do is you can find out if this equation is balanced when you have this unit. Since they both are equal, this answer is also correct. Now show that c has no units. Again, you can simply make c as a subject. This equals to, you have no units for 2, obviously. What about force? Force equals to ma. This is kilogram meter per second square divided by density. Density equals to mass per volume. So this is kilogram m minus 3. Now it would be confusing if you write this as kilogram divided by meter cube. You will have a lot of denominators and under this, and then you have area. So this is meter square, and then you have velocity. Remember, this velocity is squared, so we have to square this. It's going to be m square s minus 2. Let's write down here, m2 s minus 2. Now let's simplify this one more step. Kilogram ms minus 2 divided by kg and m. Okay, so you have m minus 3, m2, and m2. Let's add them together. 1 m, just m, and then you're left with s minus 2. Okay, now can you cancel them? Yes, kilogram and kilogram, meter, meter, s and s. So you're left with just 1. So c has no units. Let's move on to scalars and vectors. So we just studied that for a physical quantity to be complete, we need to have the number, the magnitude, as well as the unit, for example, meters. So but sometimes that is not enough. Okay, if you write 20 kilometers, that may not be enough. In some cases, you need to write the direction as well. For example, 20 kilometer northeast. Okay, so when you have your magnitude as well as direction, that is going to be a vector quantity. In cases where you only have magnitude, for example, you can say a person has a mass of 20 kilogram. That is a scalar quantity because the magnitude is enough. One more difference between both of them is that scalars can be added algebraically. For example, 20 kilogram plus 30 kilogram equals to 50 kg. But what about in vectors? You cannot add them algebraically. For example, 20 kilometer northeast and let's say 12 kilometer south. Can you add them? You can't actually, because they have different direction. There are different rules when you have something like this, and we'll explore that further. Now let's talk about distance and displacement. So we can say, for example, a person is standing here and this person traveled all this distance, let's say 2 meters, 3 meters, and so on. And if you want to find the distance, you're basically just going to add them, right? Add these individual distances to find the total distance traveled. This is the final point, this is the last point. But what if you want to find the displacement? Now displacement is you have to consider the direction as well. So displacement is simply going to be the distance from the starting point here to the final point, something like this. Now here, let's say we also have a racetrack, and this the perimeter or the circumference is, let's say, 30 kilometers. So a person runs from the starting point and all the way like this. So can you identify the distance? It's obviously 30-kilometer distance traveled by the runner. What about the displacement? Can you say what that is? That is going to be 0, because the distance from the starting point to the final point over here is obviously 0, so displacement is 0. Now can you try to identify which of these are scalar quantities and which of these are vector quantities? Okay, so mass is a scalar quantity. I'm writing S for scalar and V for vector. Weight is a vector quantity because weight also focuses on the gravitational pull. So weight is always acting down towards the earth. Acceleration is also a vector quantity. Remember, you can have acceleration, you can have deceleration. If an object is thrown up, it's accelerating downwards or having deceleration upwards. You can't think that current is scalar because we have conventional current and we have electron flow. A conventional current moves from the positive to the negative, and electron flow flows in the other way. But the thing is, we can't really follow these the laws of vector addition, okay, which we'll focus on later. So current is also a scalar quantity. Time is scalar, and so is density. Now let's talk about vector representation. How can you represent vector? Okay, so we have arrows that represent magnitude and direction. If you have an arrow pointing in this direction, that shows a direction. If you have two arrows, something like this, a longer arrow represents a greater magnitude compared to a smaller one. So magnitude and direction can be represented by arrows. Let's try to draw these. If you have 15 meters per second, due east. So you have this compass here. East is towards right. So we will draw something like this. Now you also need to show a scale. So you can say 1 centimeter equals to 5 meters per second. So when you're drawing that, you can take care of that. This would be 1 centimeter, 2 centimeter, and 3 centimeters. Okay, this is 1 centimeter, 1 centimeter, and 1 centimeter. I hope that's clear. On the other side, you have 10 meters per second due south. Let's make it, south would just be down, right? Let's say I want to call this southeast. You have 10 meters per second due southeast. That means it's going to be between south and east, something like this, at an angle of 30 degrees from east. So the angle is, this angle is 30 degrees, okay? So when you're drawing it, this would be something like this. This is 30 degrees, right? And it should be 10 meters per second. 1 centimeter equals to 5 meters per second. 1 centimeter, 1 centimeter. Use a ruler and it will be clear. And here you have to use a protractor. If you're wondering how you're going to keep your protractor should be something like this. And you have to read from here, okay, this direction. And then mark 30 degrees. Now let's talk about addition of vectors. Can you add vectors? Yes, you can. And when you add two vectors, for example, two forces, you will get the resultant force. So let's say they're both in the same direction, 10 Newton plus 80 Newton, it would be 90 Newtons. We can add them now because they are both vertical, okay? We can also add them like this, even though they're in the opposite direction, okay? They're both in the y-axis. So this is going to be 90 Newton. You have to show it with your scale that it is bigger, okay? On the other side, it's 60 and 10. Here you have to subtract both of them because they're in the opposite direction. So this is going to be 60 minus 10 equals to 50 Newton. 50 Newton upwards. You have to remove this much here. Now in cases when vectors do not act in the same direction or in the opposite direction, you can't simply add them, okay, like what we did here. Remember this example? where one is in northeast, the other one is in south, you can't just add them or subtract them, right? So you have something called a vector triangle. You have to combine them together to draw a triangle, and then the diagonal is going to be the resultant force. So if you have something like this, let's say a ship is traveling north at a velocity of 12 kilometer per hour, and then the wind is blowing at towards east at 4 kilometers per hour. What is the resultant velocity? What do you do? So you basically have to draw the first one, draw the second one like this. This is not drawn to scale. When you are drawing your vector triangle, make sure you use a ruler to actually draw it. Also, you can't really and you have to draw a scale. So let's say, okay, so you have to draw a scale of something like this. The resultant is going to be from the starting point to the final point, from here to here, and this is going to be the resultant velocity. Now sometimes a lot of students make this mistake that this is for example 12 kilometer per hour. Instead of drawing it here, they draw it here. So how do you know where to draw? I'll tell you what to do. You have to make sure that it follows the line, okay? So if the arrow is going up, the second should follow that. They are both going in opposite direction. That's not how it works. You should be able to follow along the arrow. And what about the resultant force? The resultant force is from the starting to the end, okay? And the resultant force should not complete the triangle. Like the arrow shouldn't be like this. The arrows for the resultant should not be like this. That means you can complete it like this, okay? It should be from the starting point here to here, and this is how you should draw your arrows. Now to find the resultant velocity, you can simply use a ruler to measure this. This resultant velocity is 12.6 kilometer per hour. Now this is a vector quantity, so of course it's not complete without the direction. So let's find out this angle, the angle between the resultant and one of the force. So we have to find this angle theta. And to do that, you can simply use a protractor. Let's say I got 18, so it's going to be 18. But what do you write after that? 18 degree what? So this is going to be handy. So I learned it this way: north, east, southwest. You can say never eat soggy worms. Okay, never eat soggy worms, and that's how you can memorize this. So 18 degree to what? This is moving upwards, right? So this is something like this, moving upwards, and you can say it's 18 degree east of north, okay? Logically, it's actually at north, but it's just 18 degrees away. It's 18 degrees east of north. I hope that's you can understand it. It's 18 degrees east of north. Now, so we did find the resultant by the scale drawing, right? We had a scale and then we draw it. What about calculation? Now, the thing is, with vectors, you can use mathematical calculations to find it. So since this is a right angle triangle, you can use Pythagoras theorem. So resultant velocity equals to square root of 12 square plus 4 square, and that is going to be 12.6 kilometer per hour. Now what about angle? Remember, tan equals to opposite over adjacent. You may know this from SOHCAHTOA. You may know this from math, right? So what is our opposite? Opposite is this one, 4 kilometer per hour, and adjacent is 12 kilometer per hour. This resultant is the hypotenuse, right? So this is going to be theta equals to tan inverse 4 divided by 12, and then you will get 18.4. Remember, in vectors, you can use these trigonometry rules. You can use Pythagoras theorem when you have a right angle triangle, just how as we did over here, right? But in some cases, you don't have a right angle triangle. For example, you can say the object is traveling in this direction. This is the velocity, and the second velocity is in this direction. Find the resultant from the starting to the end. So in this case, you cannot use Pythagoras theorem. You have to use sine rule or cosine rule, whatever that's helpful for you. Okay, now let's talk about what if you want to subtract two vectors. What do you do? So if you want to subtract vector A, which is moving in y direction, from vector B, which is moving in the other direction, and you have to draw a vector triangle. This is basically A plus negative of B. So you will draw A the same way, like this, going upwards. That's A. But for B, since it's negative B, you will simply change the direction. You will make it like this. That is negative B. So what is the resultant from the starting point of A to the ending? Now this is your resultant. Notice how A and B are in one direction, and then the resultant is from here starting to the final point. So that's important. Alright, so we have a couple of questions. Try to do this on your own first, and if you're done or if you can't do it, let's do them together. So two forces are 450 newtons and 600 newtons. Determine the maximum magnitude and the minimum magnitude of the resultant forces. What is the maximum magnitude? So we get the maximum magnitude when they're acting in the same direction. So we'll say 600 newtons, for example, north, and the other one is also acting north, so we just have to add them. Then 50 newtons. Now if they were acting at an angle to each other, it would be less than 150. It would be between the minimum and maximum. Okay, if the forces are acting at an angle to each other, it would be between the minimum and the maximum magnitude. Now what is the minimum magnitude? We assume that they're acting in the opposite direction, so this is going to be 600 minus 450. So this is going to be 150 newtons. Now what is the resultant force when they're acting perpendicular? That means they are acting at an angle of 90 degrees. So 600 newton, and the other one is like this, 450 newton. Find the resultant force. That's easy. You can simply use the Pythagoras theorem, 750 newton. Since these two forces are now acting at an angle to each other, so this is between the minimum and the maximum. If you want to find the angle, theta equals to tan minus 1 OA, remember TOA, opposite over adjacent, is 37 degrees. So this angle is 37 degrees. Alright, so now we have another example. These are the forces. Can you find the resultant force? Okay, if you're done. So you have 50 Newton force acting in this direction, 80 Newton force in this direction. You need to find the resultant force, so complete the vector triangle. Now if you're thinking that you can draw a triangle like this, that is absolutely wrong. You have to draw the first force first. So this is, let's say, something like this, 50 Newton, draw it at the same angle, okay? And then the second force must begin where the first force ends, so it should be something like this. So 80 Newton here. Now you might be wondering, how can you draw it when you don't know this angle, right? You don't know the angle at which you will draw it. This is not 40 now. It was 40 when it was like this. So how do you do this angle? So what we have done over here is that we just basically moved this 80 Newton up here. Now if you just care to extend this line back, you can see that all of this is 180 degrees, right? All of this is 180 degrees, so 180 minus 40 is going to give you the angle between this one. So this angle is basically 140 degrees. So now if you have a scale diagram, you can do that. If you want to find it by calculation, you can do that as well. So the resultant, and what about the direction of a resultant? It's going to be upwards from the starting to the ending. So it's here. Let's find the resultant by cosine rule. It's going to be approximately 120 newtons. Now you have to find the angle. So this angle, let's find that now. This is theta. So we can simply use sine theta divided by 80, because 80 is opposite to theta, over 80 equals to sine 140 divided by the force that is opposite to this angle, which is 120. Theta is going to be approximately 25 degrees. How will you write this? You will say the resultant force is 120 Newton. Anti-clockwise, to 50 Newton. Why anti-clockwise? Because this is in this direction, right? Your resultant force is not clockwise, not in this direction, it's anti-clockwise. So you'll say 120 Newton at an angle 25 degrees anti-clockwise to 50 Newton. 50 Newton. Now resolution of vectors is very important, and you will face this a lot during your A-level physics. So resolution basically means separating a vector into x and y components. So let's say you have an object which is traveling in northeast direction. So if you want to break down the velocity that is moving in the x direction and the velocity in the y direction, that is going to be called as resolution of vectors. So let's so this might be our graph. This is y and this is x. So you can separate this into x component and y component. Okay, now to do that you need to know the angle, either this angle or this angle. Let's say this angle is given as x. So what do? In the question that told us that is 50 meter per second northeast. Let's say this was north, this was east, so this is correct. 50 meter per second northeast at an angle of 30 degrees to the horizontal. So this one is 30. This is 50 meter per second and this is 30 degrees. Now what you have to do is you have to use either 50 cosine 30 or 50 sine 30. Now when do you know when you have to use sine or cosine? Depends on the position of angle. So to do Vx, what you have to do is you will write 50 cosine 30. Now you always use cosine when you know the angle between your force and the component that you're trying to find. So you know this angle is 30, that's why you write 30. Now here you don't know the angle, right? You can find it, but like it's not but 30 is not the angle, so you'll use sine then. So we'll use 50 sine 30. That's it. A quick way to remember is that stay away from sins. So this angle, the angle that's away from you is given, so you can use sine. Now during your studies you might come across this term coplanar vectors. What does that mean? That means the vectors that are acting in xy plane. They're all acting in the same plane. For example, if you have a piece of paper, you can draw the vectors like this. They're not acting like in a 3D position. Okay, so this is what you call as coplanar. Now we discussed vector triangles for two forces. Sometimes you may even have three forces. For example, force A, force B, and force 3. And you want to find the resultant. The resultant is going to be, again, from the starting point to the final point. That is going to be the resultant force. But now you don't have a vector triangle like how we did here. This is a vector polygon. Okay, now this is vector triangle, right? Now we'll discuss something else, which is a closed triangle. Now in closed triangle, let's say the object is in equilibrium. That means there is no resultant force. Ignore the spelling, please. There is no resultant force, no resultant moment, so the object is either not moving or it's moving with constant velocity. The acceleration is 0. That means we have no resultant force. Okay, let's try to draw this closed triangle. Okay, so you can see this object. This object is hanging from a rope. Its mass is 20 kilograms. It has a rope which is at 30 degrees to the roof, and there's another force which is acting horizontally. We have to draw a vector triangle from these three forces. How do you do it? So the first one is just start the easiest way is to start with the weight, which is acting downwards. Remember, mass is not a force, but weight is. So W is going to be mg. Okay, so you can say the weight is acting downwards. Now you have two forces, tension from the rope and the force which is acting down. Remember, tension is acting upwards, okay, because it's pulling it up. You can imagine that if you remove this rope, this object will fall over there, right? It's going to fall down. So this rope is pulling it upwards in this direction. So you have a tension which is acting here, and you have a force which is acting horizontally. Now if we draw our tension like this, tension from the rope, we can easily draw this force which is acting here. Now if you notice one thing, this is a closed triangle. You can follow this arrow completely, right? There is no resultant force. In resultant force, we don't have a closed triangle. This way, and then this way. Now you can also draw this something like this, where you can draw your tension like this. Tension is acting upwards, weight is acting here, and force is acting this way. This is also a correct representation of these forces. Now you have to show this angle as well, okay? So obviously the angle between force and weight is 90 degrees. Now what about this 30 degree? So you can see that the angle between the roof, between the horizontal and the rope is 30, and the angle between the rope and the vertical is going to be 90 minus 30. Let me just draw it like this. 90 minus 30 is going to be 60, so this one is 60. So you have to write 60 and 30 appropriately wherever it's needed. Now if you can see, the angle between the rope and the vertical is 60. So between the rope and the vertical is 60 here. Let's write 60. And then you can find this last angle by 90 minus 60, 90. Okay, and you can find this angle by sum of angles equals to 180. So it's going to be 180 minus 90 plus 60. The answer is going to be 30. But you can also see you have a 30 here between the rope and the horizontal. It's 30. So you can write 30 here. On the other side, if you see it again, the angle between the weight and the tension, weight and tension is 60, and the other one is 30. In a closed triangle, the sum of forces is 0, so you can say W plus force plus T equals to 0. Now you have another system of forces. You have W1 and W2, which are pulling up like this, and then they're going down through a pulley. And then you have W3, which is acting downwards. So the forces are basically like this: W1, W2, and W3. When we say that these forces are in equilibrium, that means there is no resultant force. So we can say the W1 plus W2 equals to W3. The forces are equal. W1 plus W2 is equal in magnitude to W3 but opposite in direction. As mentioned before, the sum of these forces would be 0. So we can write W1 plus W2 plus W3 equals to 0. Now let's say if you want to draw a closed diagram, again a closed triangle. This is not a vector triangle because there is no resultant force. So let's go ahead. I'll draw W3 first. It's acting downwards. This is W3. Then let's go with W2, which is acting here, is acting upwards. And then W1 is acting in this direction, so that would be here. W1. It's a closed triangle. It's all of them are head to tail. And this is your closed triangle for this system of forces.